Everyone. So today we are going to solve 14th of August gigs for gigs problem of the day problem. That is subset sum on generated sequence. So what is the problem it's saying is there are n children that are standing in a queue. You can consider these are the numbers that I have given to those childrens like 1 2 4 2 and for each of those childrens. And there is a starting number that is denoted by S. So there is a paper. What is the like admin? What is like problem setter is doing is it is that number is written on that paper, and that is given to the first child. What it is doing is it is just summing up all those numbers and adding his number to the paper and give it to the next child, and it is going further and further to the end of the end of the array. So we have to finally read what we have to find out. It is like we have given this X and we have to find out whatever the sequence that will become. Is there any possibility that we can take some elements and there some is equals to uh, given some that is X. So that we have to find out. So basically, let's go to whiteboard. So there were two problem statements in this. Let's divide the complete problem into two problem statements. One is you have to make a sequence from the given array. Okay, consider this is an array as s we have given and x we have given, and we have to make the first array that the final array that will made on that paper. Second thing is how to find the sum, like how to find this that subsequence that can be sum up to the x, can be or not be, that we will check. So this is the second part of the problem statement. Let's focus on the first part first. What it is saying is 1 2 4 2. So how we can generate that sequence? So initially, we have to write the first s that on the paper. First, I will do like this, and consider there is a variable that is sum, that is initial value, that is s, that we have given. So we can start from this. Now, if I'm on the first child, what it will do, it will just adding this sum value that we have till now on the paper. Consider this is a paper, and paper the value is one only. Okay, so this value is, we have came up this value, and we what we can what we need to do is we can add this child value to this sum value, to this paper value, and what is this 2, and we can write on this paper. And my paper value now is become is 3 because this 2 will also adding to the my paper value. Okay, consider the next element, that is 2. Again, this sum plus 2, it will go as 5. And this 5, now the new value will become my add to the my sum. So this will become 8. Same 8 plus 4 came as 12. And this 12 will finally will be added to 8. This will become 20. And this 20 plus 2 is 22, and this 22 now add up this will become 42. So this is finally paper value, and this will be the array that will become after this complete. Let's go the second example also to better understand this first part of the problem. So this we have given. Okay, and consider same like this is sum. So paper value is I'm denoting paper value by some variable, and you can consider another variable also. So that is sum, and initial value is this paper value, that is 0. If I am on the first child, what I will do is I will add up this sum value to this child value, that is 151, and this 151 will add up to this sum value. This will become 251. Now again, this 251 will add up to this 88. This will become 9, 853. This is become 339. And this will become 251. And this 339 will add up to this 251. So the final value will become here. So this will be the array that will become that's under 151 and 339. So this array we will get, and we have to find out are we the next problem. Then now the next part of the problem is, can we get this sum x from adding any of these values from this array, or like in this example 500 we can get it. So consider this second part of the problem. Okay, let's go come back to this part. So consider we have made this array. Now what you can analyze from this array is every element that is starting from initial element. Okay, let's go to constraints. So as you can see, s is always positive, 1 to 10 raised to power 9. So this is first element is always positive. And what we are doing here is for every other element that we are adding all the sums that we have accumulated till now plus the array of the element, and array elements are always positive in this case. So what we can say is this element, these are going in this increasing order. There cannot be a possibility that it will go in the decreasing order. Why? Because every element that we are taking care of, like, is the addition of the previous elements plus the array elements. Okay. So in this case, we can say this is a strictly increasing sequence, and array of I, there cannot be a possibility that these will be like strictly increasing sequence. Okay. So coming back to this is like, okay, so there is a mathematical problem based on this. Like what it is saying is, if you have taken any element, consider we have we have this, consider we have some element B0, B1, and B2 and B3, any element of the sequences. And if B1 is equal to, consider B1 is equals to, is greater than B0, okay, and B2 is greater than B0 plus B1, like all the previous elements that in same in our case. So these type of sequence are called the super sequence, super increasing sequence, or that we can tell them. And there is two ways. Okay, so let's not go to into that manner. First we will do is how we can find out. Okay, in the brute force approach, that my first priority is for every in the every video, as you have seen, my priority will be to solve as a beginner level. Okay, consider this sequence we have made. Okay, now we have to find out the x equals to 7. Can we get it that or not? So most brute force approach, what is that is, like, you can find out all the subsequences and you can try that out. Okay, right? So that in that manner we are going with that. Like what we can do is consider for every I'm starting from here. I have the two possibilities for this one. Either I will pick it up or either I will not pick it up. Okay, right? So consider like again we have this sequence 1, 2, and 5. Consider this I have a small sequence, and for every index, like for this index, I have a two possibility. Either I will take one or either I will not take anything. If I take one, the sum will become as one, or this will be zero. Then again, two possibility, either I will take two or either I will not take two. Same for here and same for 5. Like for every sub cases, we will find out these and finally we will get the sum. And if we are able to get the target sum or not, then we can decide. So I wrote this particular program in Java, and as you can write in your particular language also that you are preferred with. So this I have written. So first we will check like how to create the array. As we have discussed, first part of the problem, make array. This is nothing but just I am initializing array with the one length increasing, because we have to store s also in the first element, and then I'm taking as the sum as s that I've shown here, and just I'm iterating over the for loop, and I am doing the sum plus array of I. Like for each of the case, whatever the sum that I've accumulated plus array of I that I'm storing in my array, and I'm increasing that particular sum with this array element that I've calculated now. So, and finally, I'm returning the array of one. So this is just creating the array, first part of the problem. Now the second part is the important, how you calculate the subset sum. So for that part, as you can see, for this array index, and I'm initializing with 0, is just a recursion, simple recursion. What I'm doing is, I'm just checking either I'm picking it up or not picking it up. If I'm picking it up, so it means my index will be, in either case, index will be going to be increased and my sum will reduce by this array of index. If I'm not picking it up, my index will increase and sum will remain as it is. Okay. And finally, we will return like whatever the value it will return. And the base case will be if I'm out of the bound of the array, given array, and I will check if my sum is 0 in any scenarios, then it means we have achieved this. Otherwise, we have not achieved this. So this is just simple algorithm. What is the problem with this is the time complexity. Why? Because make array, this will not in this is just big of n, where n is the array of length. But the problem here is for every case we are doing the pick and not pick. That is the exponential time complexity. For every element, we are taking care as of the two choices. Either we will pick it up, not pick it up. So for every element, then again pick it up, not pick it up. So it will going to be again finally 2 raised to power n. So this is a problem here. And to optimize this, we can go to this increasing sequence manner. How we will do that? As I explained, So every element in this R sequence is greater than the sum up of all the previous elements, right? So we have a simple greedy, we can go with the greedy approach. What that approach is saying is whatever the target sum. Okay, first thing is this is just nothing related to mathematics, but just to think about this. If target sum is something 7, we cannot take 22, right? There is no point of taking the greater number than target sum. So we can just remove them. We can come about this. So this can give to us solution. Okay, we can take, okay, if we will take 5, our target sum is 7. We will take 5. The remaining sum is 2. Can we take 2? We will check. Okay. From here, we can take as 2. So if we will take 2, then we can just return, okay, 2 plus 5 is the possible solution. Same for here. 500, every element is less than this. So there is no point to remove that. So 339. Consider 339, we will take it. And the remaining will become 1 40, 61, 61. So this will become remaining. Okay. So can we take 151? No, we cannot take 151. Okay. If we will take this, the remaining sum will become 10. Can we take 100 to 10? No. There will be no solution for this example. So like this, you can just simply take this and as a mathematic domain, and you can just find it out. Okay. For that, I will also written the code. So let's see. Again, what I'm doing is I'm just creating the make array, and I'm using the array list for this. Why I'm doing the array list? Because for this time, I'm just removing the extra sums also, right? 22, 12, these are not required. So just I'm taking the only required sequences. You can also do this optimization in the make array method that we have created before. But I'm doing here this, and I'm just checking. And if you're not doing this, there will not be impact in the time complexity. So there is nothing much worried about. And I'm just iterating over the array list. I'm checking if that particular element that I'm going to pick is less than or equal to target sum, then I'm taking that element. If if it is not, then I'm going further. And if anyhow I will find out target sum might become as 0, then I'm just returning true, otherwise returning false. So it's just a simple problem. You have to think first about the that brute force approach recursion. If you are figuring it out, like how to do that, it is a very well approach. And then you can take out this example, like how super increasing subsequences sequences are working. So if you like or learn from this video, please like and subscribe my channel. And thank you everyone.